Hello and welcome back to another episode of Answer Keys with Avden, where I make an answer key. If you hear any loud noises in the background, that's just my 7-year-old getting butter for his toast. Alright, so for each of the following polynomials, you are given one factor or one root. With that information, find the other factors and roots. Then, using technology, graph the function. I don't even think this is true. You can check your answer with technology. Don't use technology because you need to not have technology for the test, I believe. Okay, so we have this polynomial, we have this factor, and so the strategy is, once you know one factor, you divide it out and take the leftovers and factor the leftovers. So let's get this factor going over here. Let's get a division problem going over here. Write the first term in the first box and kick off the process. Divide out the x, we get an x squared. But that commits us to negative 5x squared. When we need negative 4x squared, so we gotta have an x squared here to add up to negative 4x squared. Bada bing, bada boom. Divide out the x, get an x. Multiply down, get a negative 5x. That's it. We're done. We don't need this. So that means the rest of it is x squared plus x, and now I'm realizing we should have just factored out an x to begin with. That's okay, we can do it now. Factor out an x. What's left when you divide an x out of x squared is an x. What's left when you divide an x out of itself? You are left with 1. How do you know? Well, multiply back in. Okay, so it is this and this, so sweet. The roots, therefore, are 5, 0, and negative 1. Let's check for the end behavior. It's odd, so it should be shaped like this. And there is no flipping coefficient in the front, no negative coefficient. So that is the shape. So it is coming up from negative infinity, and then it goes up to infinity. So it must be doing this, coming up. I'm just gonna wing it. Oh, it goes back to, yeah, there. Cha-cha-chow. Now, if you're a curious person, you might be saying, well, what is it really doing it to? Well, great, we have the factored form. We put a 2 in. This first factor makes it a negative 3. We're putting in a 2, this is a 3. And these all multiply together to be negative 18. So this point is actually 2 comma negative 18. Ta-da! And it goes through 0, 0, of course. It'd be kind of interesting to find this point, but it's all approximate. What really matters is the end behavior and the roots and being on the right side of the x-axis. That problem's done. Cool problem. All right, we have this polynomial and this clue, which tells us that this is a factor. Let's divide it out. Oops, 2x cubed is the first term. And dividing out an x gives us 2x squared, and multiplying down gives us 2x squared. And figuring out we are short 5x squareds, we need to go with the 5x squared there. Divide out the x, we get 5x, positive. Multiply down 5x. Ooh, we are overshot, so we need negative 3x now. And divide out the thing, and we get negative 3. And multiply down, and we get negative 3, which is the last term. Of course it worked. We were given the fact that this is a root. They weren't lying to us. That is a root. That is a factor. It does go in evenly. And leaving us with 2x squared plus 5x minus 3. Now, we probably could factor this. I'll show you 2 different ways. 2 is prime, so all of it has to go in one spot or the other. And this has to be negative 3. Now, how can we add these 2 up to 5? Well, if this was 3 and this was 1, Well, how does it go to negative 3, though? We need to add up to what? 5x, positive 5? Oh, no, this is, yes, here we go. This is the 3. This is the negative 1. And this is 2x squared, and this is 6x, and this is negative 1x, and all adds together. So our other factors are x plus 3 and 2x minus 1. Now let's say that gives you nightmares. Then what you do is you just grab this thing and do the quadratic. 25 minus 4 times, oh yes, it's 25 minus 24. I love it. So square root of 1 there, and 2a. And then square root of 1 is 1, so negative 5 plus 1 is negative 5 plus 1 is negative 4 over 4 is negative 1. Uh-oh. Oh, wait, that's... No? I already have that root. Did I screw up? Let me try this again. B squared minus 4... Oh, I did screw up. Minus 4a is negative 8 times... is positive 24. That's at 49, my dudes and dudettes. All right. So this is actually negative 5. Dude, I'm recording. Negative 5. He's jamming out to some... What is that? Typing program. I don't know why you have to sing to it, but just kidding. I'm just kidding. I'm just teasing. You're awesome. I like your singing.
I'm not singing.
Oh, okay. All right. So negative 5 plus 49 is 2 over 4. That goes with that factor. And negative 5 minus 7 is negative 12. Divided by 4 is negative 3. That goes with that factor. So either find the factors this way and then make the roots, or find the roots this way and make the factors. All right, I'm pretty sure that makes no sense, but moving on. We know what are our roots. Negative 1, negative 3, positive a half. It's cubic. It's not flipped over. There's no exponent in the front. No negative coefficient in the front. So we're coming up from down here. We're diving back down. We're going through. Okay, should we try to be accurate? Let's plug in 0. It's negative 3, right? 0 plus 0 plus 0 plus negative 3. We're so accurate. I love it. Ugh. Try to make it look prettier than that. Technically, this should be curving the other way because it's faster and faster. There we go. That's better. It's a little bit better. Anything we forgot? We got the end behavior. We got the roots. Okay. The factors. All right. Now the easy stuff. Negative 9, positive 9. The I squared. Those cancel, and we get 13. X squared. That cancels with that, and 5. Negative 5. Find the equation of a third-degree polynomial with roots 2, 5, and negative 5, and an end behavior that, as x goes to negative infinity, the function goes to positive infinity. Easy. But what's with this end behavior? It's cubic. 1, 2, 3 x's in there. But it's going up on the negative side. So let's just throw a negative sign in front. Okay, we need a standard form, so we need to multiply this out. But let's start with these because it's a conjugate pair, so we know we'll get some canceling. We get x squared we get positive root 5x, and the next rainbow is negative root 5x, so those are gone, and we have negative 5. Hey, it's similar to that problem. But we're not done. We also have this. Oh, and this. So, x cubed, negative 5x, negative 2x squared, 10. But don't forget to multiply this in. So it's actually negative x cubed, positive 5x. Oh! Let's put them in order, shall we? Positive 2 x squared, positive 5x, negative 10. That looks like better. Okay, let's grab these factors. Ooh, standard form. It's not going to be pretty. Get the first one. Combining like terms. Multiplying by the last factor. Negative 4x squared. X squared. Negative 4x. Oof, it's getting intense. Negative 2x. And 8. Negative 3x squared. Negative 6x. And 8. There we go. And behavior, down on the left, up on the right. Roots with multiplicity. They're all multiplicity 1. I mean, I don't think you totally have to list the multiplicity when it's 1, but what the heck. Degree. Third degree. Y-intercept. Let's plug in 0, 0. We get 2, negative 1, and negative 4. 2 times negative 1 is negative 10 and 8. Listed as an ordered pair. Last problem. Let me get this uploaded. I'm actually going to multiply these together. X squared, we get to combine to 2x and a negative 15. And now we'll fold in the x squared. So it's the fourth degree. Plus 2x cubed minus 15x squared. That is up on both sides. So as the inputs go to negative infinity, the outputs go up. And on the other side too, because this is a quartic. A quartic. Roots with multiplicity. 0, m2. When x itself is a factor, 0 itself is a root. Because you can plug 0 in and get out 0, that's what a root is. Because 0 squared is 0 times negative 3 times 5. Well, 0 times this stuff is 0. Boom. X itself is a factor, 0 itself is a root. In this case, a double root because it's x squared, not just x. It means it's bouncing off that thing. If you're graphing it, okay, 3m1, negative 5m1. Ah! Ignore that. Am I even going to be able to scan this? It's like you have to watch the video just to get the context for all this chicken scratch. And we are done. Oh, thanks for making it to the end of the video. Here's a little cameo of Ralph and Leo from the current set. Nice.